Hello everyone, this is Heading Tian. Welcome back to watch this video. This video we are learning 2.4 graph piecewise function. What is piecewise function? A function that is defined by two or more equations is called a piecewise function. For example, a cell phone company offers the following plan. $20 per month by 60 minutes. Additional time costs $0.4 per minute. We can represent this plan mathematically by writing the total monthly cost C as a function of the number of calling minutes T. So we have a function C of T equals there are two parts of this function. First part is $20. If the T is between 0 and 60, that means the cost is $20 for up to and including 60 minutes calling. So for example, you called somebody 50 minutes this month, you need to pay $20, or you didn't make a phone call, you still need to pay $20. So if you call the minutes you call more than 60 minutes, first you need to spend $20 initial fee, and then $0.4 per minute times the number is calling minutes exceeding 60. So this part is the minute more than 60. If T is greater than 60, if we graph them, we will have the graph. So from x equals 0, between 0 and 60, we have a constant function. More than that, we will have an increasing function like this. So in this part, we will not have the word problem. Most of the time, we will only solve the problem like the following examples. So for each piecewise function, find the specified function value. First function, g of x equals x plus 4 for x is less than or equal to 1. If the x is not less than or equal to 1, x is greater than 1, we will have another function, 8 minus x. That means the interval, that means all the x value is broke into two parts. The first part is x is less than or equal to 1. So the 1 is included in the first part. And second part, I use red. Second part is x is greater than 1. So it's the parentheses and highlight this area. Let's find what is g of -4. Now the input x is -4. Let's find where is the x. Is x here? Yes, it's on the left side. If it's on the left side, we need to use the first equation. So we will use the first equation. Let's rewrite it here. P of -4 equals x now is -4. So -4 plus 4 is 0. Second one, g of 0. Where is the input at 0? 0 is 0 here? Yes, it is on the left side. We are still using the first equation. 0 plus 4, that's 4. And g of 1. G of 1, where is 1? In the first interval or second interval? Is here or here? Or on the number line? Where should I choose? Yes, it's here. It's in the first part of the interval. So we should plug in the first equation, x plus 4. So 1 plus 4, that's 5. Let's see, last one, g of 3. G of 3, 3 is here. So we need to use the second equation. It's 8 minus 3, that's 5. Okay, we'll use the same method to solve number 32. Number 32, this one, the interval or the x domain is divided into 3 parts, or is broken into 3 parts. Let me draw a long number line. Find the key points. So these are all the key points. First one is -2. Second one is 4. Oh, we only have 2 key points. The 2 key points divides it into 3 parts. The first part is a parentheses. X is less than -2. And second part is, let me use different color. Between -2 and 4. -2 and 4, they're included in the second interval. And last interval, let's use blue. So it's greater than 4. It's greater than 4. So let's highlight this area. Let's solve the problems here. So f of -4. Where is -4? X equals -4 is here in the first interval. We're using first equation, -5x minus 8. -5 times x, -4 minus 8 equals, so the multiplication of these two is positive 20. Positive 20 minus 8 is 12. Second equation, second one, the y's value, f of -2. Where is -2? It is here. So it's in the second interval. That means we are using second equation. Second equation is 1/2 times x. X is -2 plus 5. 1/2 times -2 is -1 plus 5 is is positive 3. Oh, why I'm doing this? Because it's late. Maybe I'm so sleepy. So be careful. Here is 5. So copy the 5 here. Then you must have a positive 4. Let's see next one. F of 4. Where is 4? So 4 is here in the second interval. Let's use the second equation. 1/2 times 4 plus 5 equals 1/2 times 4. That's 2. 2 plus 5 is 7. And the next one, f of 6. Where is 6? 6 is here. So we're using the third equation. 10 minus 2 times x, and x is 6. Is 10 minus 12. That's -2. We solved this one. Let's see next part. Domain of each piecewise function is -∞ to infinity. First, graph each function. Second, use your graph to determine the function's range. So how to graph a piecewise function? You see, if the piecewise function has 2 equations, that means it has 2 kind of behavior. And in chapter, so in unit 2.4, we are only graphing the linear equation or linear line. So the line should be a straight line, or straight line like this, or it's a decreasing straight line. So how to decide a straight line? So you may say, if I have 2 points, line them up, I can make a straight line. So how about if I have three points? Maybe you can decide a straight line more accurately. Even my graph is not that accurate. So let's pick 3 points. So make a more accurate graph. Okay. So let's see the right-hand side of the function. That means x is divided by 0 into 2 parts. So the all domain is broke divide 0 into two parts if I draw a number line. Here is 0. So on the left side of the 0, x is less than or equal to 0. We're having one behavior of the function. On another side of the function, let's use different color. It's another behavior of the function. So let's plot 3 points here. For example, I'm using this. Let's plot 3 points here, and then maybe 3 points here. Then line them up. We can find the graph of the function. Let's pick some points. Let's draw a table. Here is x, here is the y. From the first part of the function, we can pick some point. What should I pick? I can pick -2, -1, and 0. How about this? We must pick 0 because 0 is the end point. If I want to graph the accurate function, linear function, I must have the end point, or you see endpoint 0 here. So let's find the y's value. If we have all the x value, we are using the first equation, find the y's value, 2 times -2. And the next one is 2 times -1. And next one is 2 times 0. Let's simplify the point. Maybe we can just give the number here, make it easy. So 2 times -2, -4. 2 times -1, -2. 2 times 0 is 0. We have 3 points. How about second behavior, x and y? I will put 0 here, 1, 2. And so if x equals 0, y is 2. X equals 1, y also equal to 2. X equals 2, y is still 2. So are you going to ask me any question? Why am I going to put 0? X is equal to 0 here. X equal to 0 is not in the interval of the second part, because it will help us graph the more accurate function. So let's see it from the graph. So let's find 3 points from here. They are -2, -2, -4, -2, -4, first point. Second point, -1, -2, -1, -2 here. Next point, 0, 0 is here. So let's draw a straight line. It's going down. Another part, we're starting from 0, 2, 0, 2. I know that this point is not on the second part of the graph, so we use an open circle. Second point is 1, 2, 1, 2. This is solid line. Solid point. Next one, 2, 2, 2, 2. Then we can graph them using a straight line. Line them up. So let me explain why I have 0 here. Make it in red. So why I have 0 here? If I don't have a 0, I'm starting from x equals 1. So 1, 2. This is my first point. Second point is 2, 2. I have my second point. Then I line them up. I will have a straight line like this. How about the segment between? So between x equals 0 and equals 1. So how about this? We will miss the data or miss the point here. That's the reason I'm starting from x equals 0 here. So I will not miss any information between x equals 0 and equals 1. So I will not miss the blue segment here. Even I know the 0 is not in the domain of the second part. So I can put a mark here. This is open circle. Because 0 is not a point in the second behavior. Okay, so now I can use the red line to graph the second behavior or second part of the equation. Okay, let's practice next example. Number 47. F of x equals x plus 3 if x is less than -2. F of x equals x minus 3 if x is greater than or equal to -2. The first part, the first step, I will find the key point on the number line, that is -2. That means I can find some points in these two intervals. So in the first interval, x, y, I can pick some point. What should I pick? I can pick, let's try -4, -3, and -2. Remember, even I know -2 is not in the first interval, but -2 is the key point. I must have it here. And then you mark it. This is open circle. And let's find y's value. So use the first equation. -4 plus 3 is -1. And -3 plus 1, -3 plus 3 is 0. -2 plus 3 is +1. We got to 3 points. And in the second interval, x, y. So let's pick some points. The key point must be picked. Key point is -2. So -2. And how about -1 and 0? So y's value, x minus 3, -2 minus 3, -5. -1 minus 3, -4. Sorry, -4. 0 minus -3 is -3. We got 6 points. Let's plot them on the graph. First are 3 key points. -4, -1, -4, -1, -3, 0, -2, 1, -2, 1 is here. So the graph is all the way going down because we are looking for the x is less than or equal to 2. So it's going down this way. You cannot going up this way, because if it's going up, the value here, the x is greater than -2. So we can only graph this the part going down part, or going to the x going to the -infinity part. And let's draw another part of the equation. So the first point is -2, -5. So -2, -5. Second point, -1, -4, -1, -4. Next point, 0, -3. Okay, the x value is greater than or equal to -2. So all the way going up. You can also plot more points. Here is one question, open circle. So this point, do I have open circle? No, I didn't have open circle. So remember, here must be an open circle. So I use open circle here. And another point here is a solid circle. Let's find the range. Oh, the previous one, I didn't find the range, but it doesn't matter. Let's solve the range first from this example. Okay, the range. So look at here. The y's value is all the way going down, approaching to -infinity. The y's value is all the way going up, approaching to +infinity. So the range could be any value on the real number system. So the range is from -infinity to infinity. Range means all y's value. And previous example, let's see what is the range. So let's see we can find the range from the graph. So don't worry about the function here. So only focus on the range. Only focus on the graph. So all the way going down, approaching to negative infinity, that means starting from negative infinity. And then all the way going up, stop. So we stop here. Here, y's value is 0. And that point is included. So we use brackets. And how about the y's value of this horizontal line? This horizontal line only has one y's value, which is 2. So union 2, because 2 is not the interval, it's one element. We use a set. Okay, let's see next example. This is a challenging one because this one has 3 equations. So 3 kind of behaviors. First, let's find key points on the number line. So first key point is -3 and 4. We have 2 key points. And these 2 key points divide the line into 3 parts. First part is from -infinity to -3. And second part is from -3 to 4. We can highlight the area between. And the last part is from 4 to positive infinity. You see, I'm using the brackets and parentheses differentiate if there is an equal sign or not. Let's pick a point. Pick 3 points here, 3 points here, 3 points here. And in each interval, we must have the key points, these key points. Even it's not in that interval, but we still need to have the key points. Let's see. In the first interval, x, y's value, x, I can choose -5, -4, and -3. We must have -3, important. And here, this is a solid circle, so we don't need to make any mark. But in these 2 area, so these 2, -3, -4 in second interval, we must have open circle. Okay, let's find y's value. X equals -2. X equals -5. -5 plus 1 is -4. -4 plus 1 is -3. -3 plus 1 is -2. Let's see the second equation or second interval. X value, I must say -3 and 4, because these 2 points, they are the must choose points. And in the middle, I can choose any point. I can say 0. Because 0 is between -3 and 4. Y's value, if x equals -3, y is -1. X equals 0, y is still -1. X equals 4, y is -1. Remember, so you can make some mark here. These 2 points, they are open circle. You can put a word or you can put an open circle there. So last interval x, y. So I can choose some points in the third interval. Let's start from 4, because 4 is the end point. I must have it. And how about, so I can choose 5, but I prefer to choose 6. Why? Because I'm looking at my expression of the equation. This is 1/2 times x. If the x is an even number like a 4, 6, 8, so the result could be an integer, could be an easy number. So I can plot it easily. So I choose 6. So let's try x equals 8. So 1/2 times 8 is 4. It's easy to be found from the graph. So y's value, x equals 4, y equals 1/2 times 4, that's 2. X equals 6, y equals 1/2 times 6 is 3. X equals 8, y equals 4. So we found these 9 points. Let's find them on the graph. So -5. Next time I will put on a glove because when my my finger is moving on my screen, it will move the screen, move the lecture notes. Okay. Let's see. First point, -5, -4. -5, -4 is here. Second point, -4, -3, -4, -3, and -3, -2. Okay, here. And then we must draw it going this way because this interval is x is less than or equal to -3. I cannot going up because going up, x value is more than -3. Could be 4, 5, and 6 or positive number. So next part is first point is -3. Oh no. So first point is -3, -1, -3, -1. Now I must be careful because this is open circle. And next point, 0, -1, 0, -1. So open circle, 0, -1. It's a solid point because it is the point we can choose. Next point is 4, -1, 4, -1, also open circle. So line them up. This is a constant. So find the other 3 points. 4, 2. So 4, 2. First point. 6, 3. 6, 3. And 8. I don't have 8 here, but I can draw more points on my coordinate plane. So 7, 8. So 8, y's value is 4. So it's an increasing line. Okay, we found our graph. And let's find the range. From the graph, you see where is the lowest point? It's going to -infinity. So starting from -infinity, and then stop here, y's value is -2. -2 is included in our range. So next part of the range is the straight line. Here is the horizontal line. It only has one y's value. That's an element. So we use a union and the set notations. We put -1 in it. And the next equation's behavior is all the way going up. So the starting point here, y's value is 2. Union 2. 2 is included. It's a solid point to infinity. Okay. This video covers everything in chapter 2.4. I think it's 2.4. Okay. If you have any question, please let me know. See you next video. Goodbye.